Alright class, this is 6.3 division properties of exponents. This is very similar to yesterday. We are going to have rules 6, 7, and 8 today. And then I'll give you some examples, and you're going to find, again, same thing I like about this. If you can't remember the rule, you can prove it to yourself. Just write it out until you see what's happening. The other thing you're going to see is that there's a lot of overlap in the rules. So you and the person next to you might take different steps to get to the same spot, but you can get to the same spot many different ways. So, division properties of exponents. First thing I'm going to have you do is I'm going to have you pause at this screen, and I'm going to have you go through and write all of these down. Leave yourself a little room because we'll go back and put some examples in, but just put these in your notes first so that I don't have to waste time, and then we'll go back and do some examples. Okay, so the first one here is the quotient power. This is very similar to the product of powers. We're going to do a quotient of powers, and hopefully you know that the word quotient means divide. So here would be a quick example. If we're going to do something like this, 3 to the 5th over 3 squared. Again, very simple rule, but if you can't remember it, let's write this out. The top here means 3 times 3 times 3 times 3 times 3. The bottom means 3 times 3. And what happens to a 3 over a 3? Those are going to cancel out. So when those cancel out, you can look and you can see how many 3's are left. There's going to be 3 to the third. So hopefully you've already figured out the rule. The quick thing is that you just subtract the exponents. I want to do another example for you though. If I have something like this, x to the 2 over x to the, I don't know, 4. This is x times x, x times x times x times x. These two are going to cancel out. You have 2 x's left, but where are they at? They're on the bottom. So there's going to be x squared, and it's going to be on the bottom. So you could go about this 2 ways. You could just subtract. You could do 2 minus 4, and you would get x to the negative 2, but then we know that's not happy, so we would ship it to the bottom. The way I like to do it is I always just subtract, but wherever the bigger number is where the extras are at. So if the 4 is the bigger number, the 4 is right here on the bottom, that's your bigger number, that's where all your leftovers are going to be, so that has to stay on the bottom. So that's rule number 1. Let's do some examples. So right here, the quick and simple rule, just subtract. So this is going to be 2 to the 5th. Just subtract. 4 minus 3 is 1. Now we're going to combine some of the things that you did yesterday. So yesterday you learned this right here. This is a product to a power. So you have to do this and you have to do this. So we get D4, E3, D2, E2. So right here, 4 minus 2 gives me D to the 2. 3 minus 2 gives me E to the 1. And you can put that 1 on there. You can take it or leave it. Hopefully you're doing some pausing here and you're trying some of these before I give you the answer. If we look at this one right here, you can put all the little 1's in there where they're missing. I do 2 minus 1, but in this case, where are my leftovers at? The bigger number's on the bottom, so I'm going to have more left on the bottom, so I have a 3 to the 1 left on the bottom. Right here, 4 minus 3 again, and again, my extras are on the bottom, so I'm going to have 1 left on the bottom, and 2 are left on top, because our bigger number's on top. So, that is rule number 6. Let's go back here and look at rule number 7. Rule number 7 says a quotient to a power. This is very similar to yesterday's. It's going to feel very similar. This is just distribute the exponent to everything you see. So if I have something like this, if I have 2/3 to the 4th, again, you know what the rule is, but if you can't remember, just write it out. This is 2/3 times 2/3 times 2/3 times 2/3, which means I have, if I mush all those together, I have 4 2's and I have 4 3's. So same as yesterday, we're going to distribute this but we're going to make sure that it goes to everything. So yesterday I told you split everything up first. So if I gave you something like this, 2x squared over y to the third. Split everything up before you start. If you want to put ones on everything, do that. And then we distribute. So I get 2 to the third, x to the sixth, y to the 3. And again, it's a new rule, but it feels pretty much exactly like the one you did yesterday. So let's go do some examples of that. And again, make sure you're pausing and trying some of these and then go back and double check. So, a couple warnings. Warning number 1 on this page, make sure that you work inside out. That would be for this problem right here. Warning number 2, this is just to make your life easier. Simplify first. And that would be for something like this problem right here. You don't have to, you'll get away with it, but it'll make your life twice as easy if you do. So let's go back here, we do this example, we get 4 squared over 7 squared. That's nice and boring. Look inside here, is there anything that you can simplify? You can't, so we're going to split all this stuff up, put our 1's in here, and I'm going to get 3 to the 4th, d to the 8th, e to the 4th, f to the 4th. Okay. Can you simplify anything here? You can't, so we're going to go here, we're going to get 2 to the 6th, 3 to the 4th. Right here we're going to work inside out, so this is from yesterday, so we're going to do this first. So we're going to get x3, y3, and that's going to be gone. And is there anything I can simplify? There is. I can cancel this x3 over x3, and x3 over x3 is going to be x0. What's anything to the 0 power? It's 1. So this is just going to disappear. So now this goes here, and this goes here, and I get 2 squared over y6. Take a look at this one, split everything up, put your 1's in there. Is there anything that you can do to simplify it? There's nothing that cancels. So we go A5, B20, C10, D15. And that is that rule. Oh, one more. Take a look at this one down here. Is there anything that you can do to simplify? So the rule we just learned, we're going to subtract those. So all of these disappear, and I'm only left with a 1 right there. And we're going to subtract those. This is going to disappear, and we'll be left with a 1 right there. So when I distribute, I get A3 over B3. If you simplify first, the problem is twice as easy. Let's go back to the last rule, right here. Quotient to a negative power. This is basically just a duplicate of number 7. Honestly, you could get away without it, but it will make your life easier. So this is what it's saying. If I have something like, we'll do the same example up here. If I have 2x squared, y1 to the negative 4. The rule is if you take this whole entire thing and you flip it over first, so you turn it to y1, 2x squared, and you change this to a positive 4, then it's the exact same thing. Then you get y to the 4th, 2 to the 4th, x to the 8th. Now you could just do rule number 7. If I just do rule number 7, this is what I'm going to get. I'm going to get 2 to the negative 4, x to the negative 8, y to the negative 4. But then what's going to happen? None of that stuff is happy. So if none of that stuff is happy, I'm going to have to go back and I'm going to have to make it all happy, which means I'm going to have to shift this down. I'm going to have to shift this down. And I have to shift this up. And when I do that, you're going to notice that I get the exact same answer. So it just makes your life a lot easier if you just flip it over before you ever start, and then you don't have to deal with all those negatives. Let's do a few examples of this. Okay, so if I flip this over, I have 4 thirds to the 3, which means I have 4 to the 3, 3 to the 3. This stuff right here, if I flip this over, 3 over 2 to the 2, 2n, 6n to the 3, so that gives me 3 to the 2, 2 to the 2, 2 to the 3, n to the 3, 6 to the 3, n to the 3. And now all of this stuff is just mushed together. It's all just one problem. So now I can do some canceling. This is going to cancel with that. And only leave one of those there. And since these are just plain old numbers, we should be very careful in this situation because there might be, we need to reduce our numbers and there might be more reducing that we can do here because I know 3 goes into 6. So we might want to expand this one out. When I have 9 times 2, I get 18, and 3. 6 times 6 times 6 is 108, I believe. And Q. Now, those are both even numbers, so I know I can reduce them. So you have to be careful when there's lots of numbers in there. You might want to expand them out and make sure you can reduce if you can. So this is 9 over 54, and that is also 1/6. So this is 1/6 n cubed, n cubed. Let's see. I don't think any other one look really exciting, so I'm going to skip those because they're pretty similar to the last slide. One more thing to tell you about. Oh, 2 more, I lied. So this right here, this is basically just a list of all the rules, except they forgot one. No 0 powers. This is basically just all the rules. If you get done and you have anything to the 0 power, you gotta fix it. If you get done and you have anything to a negative exponent, you gotta fix it. If you get done and you have anything that has A's in 2 different spots or X's in 2 different spots, you have to put them together. So this is basically just a summary of the rules. You can write it down, you can take a look at it. But this is all the stuff that just tells you you need to keep going. One of them right here you have to pay attention to is that basically this means reduce your fractions. So if you get done with the problem, it looks something like this, and you have numbers on the top and bottom that are still the same, you've got to reduce that to 5 over 2. So very similar to the one that we just did right here. So if you can't tell, you might want to expand it out and double check, because I know 3's go into 6's, so there's a good chance I'm going to be able to reduce that. Last thing, let's do a quick scientific notation problem and then we'll be done. So if I give you something like this, 6.2 times 10 to the negative 3 divided by 4.7, I don't know, I'm going to do 3.1 because I don't know what 4.7 is in my head. 3.1 times 10 to the negative 5th. So, same as yesterday, just follow the rules. If I do this, I have 6.2 times 10 to the negative 3, 3.1 times 10 to the negative 5. Now, you don't have to. You can just subtract, but then you have to be very careful with your minus and minuses and all that. I really like to just make everything happy before I start. So I'm going to make this all happy. 6.2 is fine, it can stay home. 3.1 is fine, it can stay home. 10.3 is not happy, I'm going to send it to the bottom. 10 to the third, I mean. 10 to the 5th is not happy, I'm going to send that to the top. And now I just divide these numbers out, which gives me 2. Subtract my exponents, the bigger numbers on top, so that's where my extras stay. And I have times 10 to the 2. So, there's a few examples for you. Hopefully that's enough to go back and look at. If you have questions, I'll be back tomorrow. Don't worry, if there's too many questions, we'll take the time to answer them and we'll delay the quiz by a day, but you guys should be all set. Have a good day. I'll see you tomorrow.